In example 3, we're going to complete the following proof, and we may not need all the statements. So all we're given here is that angle A, all we're given here is that AB is parallel to CD. So we can go AB here, and AB appears to be a line, so let's use our line symbols there, and CD is also a line, so we'll go like this. So, oops, that's going to be parallel to CD. Alright, that's given, so that's good. We want to prove that angle 2 is congruent to angle 3. Well, if these two lines here are parallel, you can use your parallel marks, then this angle, angle 2, and this angle and angle 3 here, well, they're in the same corresponding location. You can imagine if you took this group of angles and just shifted them down so that the intersection is the same as this intersection, 2 would be right on top of 3. They'd be in the same location. So we know that they're congruent already. We don't even have to use any of these statements down here. We're asked to prove that angle 2 is congruent to angle 3, and we can actually do that right away because corresponding angles are congruent. Now there's another way to do this. You could have, if you wanted to, you could have proven that angle 1 and angle 2 are congruent because they're vertical angles. You could prove that angle 1 is congruent to angle 3 because they're alternate exterior angles, and then by the transitive property you could have proved angle 2 congruent to angle 3. That would probably have taken all these 5 steps. But I think the easiest approach to this, and the most efficient, would be to just state that they're congruent because they're corresponding angles.